Hi, this is Nimla Rednam. In this video, we are going to continue the topic squares and square roots, which is the fifth chapter from NCERT textbook class 8. In the previous video, we looked at exercise 5.1 and how to find square of a given number, and looked at a few, wherever possible, we looked at few shortcuts to find that, right? Now here, we are talking about a square root. What do we mean by a square root? If you remember, we started off the topic when we started off the topic, I told you that when we are talking about square, the origin of this word is from geometry, and which is a square, which is nothing but a quadrilateral, which is both equiangular and equilateral, remember? And I said area is equal to a square. Now here, if you are given a number, a perfect square, how do you find that number which was multiplied by itself to get this particular number? That is nothing but your square root. That is the inverse operation of square. So to say that we know that addition and subtraction is an inverse operation of addition, okay, and division is an inverse operation of multiplication. Similarly, square of any number, okay, when you're saying square root denoted by the symbol is nothing but the inverse operation of squaring a number, okay. So in this case, when that means that when you're saying finding a square root, you're interested in that number which was multiplied by itself in order to get the number given to you, right? So that is square root. Now here, it is important to note that given any number, for example, let's take the number 16, okay. Now when I say square root of 16, okay, clearly you know that 4 square gives you 16, right? So square root of 16 is equal to 4, right? But here every number has two square roots, okay. One is the one which is obvious to us, which is plus 4. Another one is the negative of the same number, minus 4 is also a square root. How do you know that? If you multiply minus 4 by itself, minus 4 into minus 4 is going to give you 16 again. That means minus 4 also qualifies as a square root, right? So any number given to you, when you're finding square root, you are going to get two values, and both are going to be with the same mod value and opposite signs, plus or minus. Both will satisfy the criteria. Now, the only thing is here, for example, if the question that we are considering is in geometry, for example, side of a square, clearly you're going to rule out the negative number because you can't have a square with a negative side length, right? So that is how the negative values get, kind of ruled out in depending on the question that is asked you. But otherwise, mathematically speaking, both are equally correct. So any number that is given to you, you are going to get two square roots. One will be with the positive sign, the other will be the same value with the negative sign, right? So here, although in the textbook they have mentioned that the symbol represents only the positive value. That is something I don't think that is correct. I have never read it anywhere. This symbol, square root of any number, you're always going to get two answers, okay. However, for these exercises that we are considering right now, the 5.3 exercise in this chapter for class 8, we will be considering only the positive value that they have mentioned in the before the exercise itself. So we are going to do that. We will consider only the positive value, okay. But like I said, both values are equally correct, right? So here, now let's come to how do you actually find the square root. Now, if you remember, we had looked at repeated subtraction. If you remember, repeated subtraction was one method of checking if a number is a perfect square or not. Why? Because we made an observation that when you add odd numbers starting from 1, the sum is always a perfect square. From that, we realize that if I consecutively subtract the odd number starting from 1 and end up with 0, then the given number is a perfect square, right? Now here, that method can be used to find the square root. Why? Because we have seen the number of steps that we follow to arrive at 0 is nothing, number of steps is nothing but the square root, right? So they have given us a few questions. Let's look at those, solve those, so that you'll understand what is this repeated subtraction. So this is the first method that we are talking about in order to find the square root. Okay, so here find the square root of 121 is the one question they have asked, and then they have asked find the square root of 196. Okay, and later on they have given quite a number of numbers, and they're asking us to find the square root using this repeated subtraction. Let's start with 121. If you remember, we had actually done it 121 in the last class. So let's start with 121. Repeated subtraction, I'm going to start with 1. This will give me 120. Now 120 minus 3 is going to give me 117. 117 minus 5 is going to give me 112. 112 minus 7 is going to give me 105. 105 minus 9 is going to give me 96. 96 minus 11 is going to give me 85. 85 minus 13 is going to give me 72. 72 minus 15 is going to give me, I have 7 here, and 57. 57 minus 17 is going to give me, I have a 0 and I have 4 here. 40 minus 19 is going to give me 21, and here I get 0. 21 minus 21 is 0, right? Now I'm going to count the number of subtractions that I have done. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So that means that square root of 121 is 11. I'm writing only the positive value because I mentioned we'll consider only the positive answer, right? So this is about the repeated subtraction method in order to find the square root. Now in the textbook, they have given a lot of such sums where they're asking us to find the square root. It's the exact same method. I want you to try these sums, right? So for example, here they have asked square root of 196 using repeated subtraction. And if you go further down here, they have given 5 more sums where they're saying, uh, first of all, decide whether it's a perfect square or not. Clearly, if you get a 0, it's a perfect square. If not, it's not. If it is a perfect square, then you will count the number of subtractions you have done. That will give you the answer. Okay. So that is one method of finding the square root. Now, what is the next method? This is repeated subtraction method. Next method to find square root of any given number is prime factorization. So what are we doing here? What do we mean by prime factorization? Any number that is given to you, writing that number in terms of product of prime factors. Okay, any given that is given to you, when you write the number as a product of its prime factors, then you say that it is prime factorized, right? So for example, let's take any number that they have mentioned. They have given 324 here. So you have 324. How do you proceed with prime factorization? You will start dividing using the prime factors. Okay, so I can't use it is divisible by 4, but I'm not going to use 4. It is divisible by 6 as well, but I'm not going to use it because I want only the prime factors. Okay, so I'm going to take 2 ones, 2 6, 2 2s, 2 8s and 1s. Now 2 is not going to work, so next prime factor is 3. Let me look at 3. Okay, 3 2s is 6, and then 3 7s is 21. Again, I'm going to take 3 9s is 27, and then 3 3s. Okay, that's it. this is my this is the method in which I'm going to prime factorize the given number, right? So now I'm going to write it as 324 is equal to 2 into 2 into 3 into 3 into 3. You can see that there are 4 threes here. Okay. So now how do you use this information to find the square root? You're going to pair up these prime factors. Okay. So in the square root, I'm going to write 1 for each. The logic is very clear, right? Because why are we using 1 for each? Because square root of this 2 into 2 is 4. So square root of 2 is 4 is 2, right? Square root of 9 is 3, so on. So when you take the product, you're going to get this, which is nothing but 9 2 is 18. So 18 is your answer, which is the square root of 324, the positive square root of 324. Now that is one method of finding the square root. Now this prime factorization can be used for deciding whether a number is a perfect square or not also. How? Because once you do the prime factorization, if you see that there is one or more prime factors which is appearing odd number of times, that cannot be paired up together, then it means that it's not a perfect square. There's no way that the given number is a perfect square. Okay. So it can be used for that as well. Let's look at the solved examples once. Here they have given 6,400 and they're asking us to find the square root of that. Okay. So you can see that they have done prime factorization here. Okay. And you're going to find the square root. Next they have given, see the prime factorization for 6,400. They have done it and they have found the square root by pairing the prime factors. Okay. Next is 90 a perfect square? Again, you can find whether the given number is a perfect square or not by prime factorization. You can see that clearly here you have 2 which is not paired and 5 which is not paired. Therefore, it is not a perfect square. That way you can decide whether the given number is a perfect square or not. Next, they are talking about 2352. Now they're asking, is this a perfect square? Again, you will do prime factorization, and if not, find the smallest multiple of this, which is a perfect square. Now, what do you mean by multiple of the given number? Now, if you look at the prime factorization here, you will see that 3 is not paired. There's only one prime factor which needs pairing, right? Now, here, if I multiply this with another 3, then clearly all the prime factors are paired up, and that means that I have my perfect square. Therefore, you can say that we need to multiply the given number with 3 and you will see that the result is 7056. So 7056 is the the number closest to 2352, which is a multiple of it and a perfect square. Okay, that kind of questions will also be asked. Next, another way of asking a question is, now what is the smallest number by which 9408, the given number, must be divided so that it becomes a perfect square, so that the quotient becomes a perfect square. Now here what you will do is, instead of multiplying with the unpaired number, here again 3 is the prime factor which is not paired. Here what we will do is, we are going to divide the given number by 3. That is, you simply take this off. Then the resultant is going to be, this number, which is nothing but 3136. So you will say that the smallest number by which it should be divided by 3. And what is the square root of the resultant 3136? The square root is going to be 2 into 2 into 2 into 7. Okay, which is nothing but 8 into 7, which is 56. So this is another way of asking the question. And next, in the 8th example, they're saying, find the smallest square number or perfect square mean the same thing, which is divisible by each of the given number 6, 9, 15. Now, if a number has to be divisible by all the numbers that they have given, that means that the given number is a multiple of the numbers given, in this case 6, 9 and 15. That means it is a common multiple, and they're saying it is smallest, therefore it has to be the least common multiple. So they're finding the LCM here. You can see here they have found out the LCM of 6, 9 and 15. Now what they're saying is the LCM they found out as 90. Okay, 90 is the LCM for 6, 9, 15. Now what is the smallest square number? Perfect square. Now 90 is clearly not a perfect square. Now I need a multiple of this, right, to find and the smallest multiple of this, which is divisible by all these three numbers. So how do you find that? Now again it's same like trying to make it a perfect square. I'm trying to make 90 a perfect square, not by dividing, taking away some unpaired factors. I need to pair them up because I want the multiple of this. Okay, I can't take away the, for example, 90 prime factorization has given me 2 into 3 into 3 into 5, right? Now 2 and 5 are not paired. Okay, so if I take this off, I will no more have some multiple of 6, 9, 15. Okay, I can only make it a bigger number by multiplying with unpaired prime factors. So I'm going to multiply it with 2, 1, 2 and 1, 5, and that will make it a perfect square. Not just any perfect square, it is the smallest perfect square that is divisible by each of these numbers. How do we know it is the smallest perfect square? Because we found out the LCM, smallest perfect square which is divisible by each of these numbers. How do we know that? Because we found out the LCM. So these kind of questions are also asked in the exercise, right? So that is about the square roots. So in the next video, I'm going to solve exercise 5.3.